Today we're in section 6.1. This is on page 350. It is the Check Your Understanding. So if you want to follow along in your book, you can. North Carolina State University posts the grade distributions for its courses online. Students in Statistics 101 in a recent semester received 26% A's, 42% B's, 20% C's, 10% D's, and 2% F's. Choose a statistics student at random. The student's grade on a 4-point scale, with A equal to 4, is a discrete random variable x with this probability distribution. So because we have a probability distribution for a discrete random variable, we're able to see each value that x can take on and the probability of it taking on that value. So we're going to use that to answer the questions below. So number 1 says, say in words what the meaning of probability x is greater than or equal to 3 is, and what is this probability? So we can see that probability that x is greater than or equal to 3 is these values here and these values here. So as far as finding that, we're just going to add those two together. So the probability that x is greater than or equal to 3 is going to be 0.42 plus 0.26, because they are mutually exclusive. We can just add them together and we get 0.68. Now what we've just found is these two added together, which goes back to the definition of what x was. So that tells us that about 68% of students will score a B or better. Then moving on to number 2, it says write the event the student got a grade worse than C in terms of values of the random variable x. What is the probability of this event? So the student got a grade worse than a C. This was the A's, this is the B's, this is the C's. So if they got a grade worse than a C, that means they got one of these two grades. So I would say the probability the student got a grade worse than a C would be that they had x less than 2. And then it says, what is the probability of this event? We would just be adding these two together. Again, mutually exclusive, so you can simply add them. So 0.02 plus 0.10 would give us a probability of 0.12. And then finally in number 3, it says to sketch a graph of the probability distribution and describe what you see. With this information, I would just sketch a histogram. So we're going to have x on our horizontal axis, and x takes on the values 0, 1, 2, 3, and 4. And then along the vertical axis, we would have the probabilities. And the highest probability, if we look back up there, was 0.42. So let's say I go up to 0.5. And we're just going to create this histogram. So I've created a histogram where each of the heights is as tall as the values are over here. So remember, we always want to label. So we have x labeled here. I should also have probability labeled for our vertical axis. Then it asks us to describe what we see. Remember, you're going to go back to the idea of socks. This basically is a single variable. Well, it is a single variable. It just happens to be a discrete random variable. So we're going to do the shape. Looks like it's skewed left. Our outliers, it doesn't appear to be any. Our center, for this I can use the median. Going back to this data that we know that we had up here, that would mean our median is going to be about 3. And our spread was from 0 to 4. So we're just going to write that out in context. So So writing that in context, I have the scores are skewed left with most students earning an A or B. There are no outliers in Stats 101. The median score is a B, and the scores vary from 0 to 4. Notice a lot of this is going back over things you've learned in different places. We talked about mutually exclusive and probability, and here we're creating a histogram and going through our SOCs. So it's time for us to start to put these ideas together.